Hello everyone, my name is Kumar. I am very much excited to share my internship experience in embedded system. And over the past 4 months, I worked extensively in the microcontroller program and real-time interfacing and embedded applications. So this presentation will cover everything I learned, including the theoretical concept and projects, which I have done. I included the key technology which I have the explored too. My 4 week journey in the embedded system developed through the hands-on microwave simulator project using PICSIM and the PIC16F8778 microcontroller. Now I am going to next slides. Okay, it's late sometimes. Okay, now I am going to tell me about the company. Industry leader is embedded training. Emertxe stand as a Bangalore premier embedded system training institutes, renowned for the bridging the gap between the academic theory and the industry requirement through the practical project-based learning. It is located in Bangalore and it is India's technology hub, specialized in the embedded system and IoT training. Industry aligned with the serving a curriculum with expert mentorship and it's giving me hands-on learning philosophy. The institute emphasizes the experimental learning through the real-world embedded system projects, ensuring the students gain the practical skills that directly translate to professional environment. This is a 4 week intensive internship program. It's a state-of-the-art development tools and simulators focus on industry standard practice and workflow, in which we use MPLAB IDE simulators, that is tools, and now we go next slides. Its main focus microwave oven simulators for project working. Project objective design and simulate the fully functional microwave controller system that replicate the real world cooking operate including multiple modes like grills, mic, um, micro convections and starts. The timing and safety features are also included. Development platform. It is a development implemented using the embedded C programming on the PIC16F877A microcontroller. Revising its robust peripheral set the interrupt capability for the real-time control. And we use a simulation environment like PICSIMLAB. It is a powerful simulation tool, provide a virtual hardware testing integrated with MPLAB IDE and in which we use X8 compiler for seamless developments. Main functionalities of the my this project. First is user interface input. Second is usual display system. Third is the timer management. Fourth, audio feedback. And five, safety mechanism. In the first user interface input, it will give 4 cross 4 matrix keypad in which we give the input uh, to command as a command to our device. This is a user to select the cooking modes before we reheat, grill, microwave, and visual display system in which for 16 into cross 16 cross 4 character LCD provided real-time feedback displaying current cooking mode, and a countdown timer is also showing in the display, and temperatures setting and system status management messages for the enhanced user experience. Thoughts time management. Interrupted driven time. implementation ensures accurate real-time countdown management allowing to pause the resume and stop operation. It's so which we we want to give the task to our device and safety mechanisms. It also included cells when integrated door sensors interlocked ensure microwave operation and when door is securely closed, preventing hazardous operation and implementing critical safety protocols. Hardware and software development stacks. In hardware component, pick 16F at 77A microcontroller, which is used as a memory on of the systems. It is the 8-bit RISI architecture with a 14 pins and 8K flash memory and 68 bytes RAM and is a peripheral set including timers, ADC, analog to digital converter and a communication interface. In input and output peripheral, a 4x4 matrix keypad for user input in which we give input like 1, 2, 3, etc. And 16 cross 4 LCD display module in which this is showing the what task we performing and buzzer for the audio alert in which we use buzzer as a alert alarming system when system food is cooked then buzzer is automatic give the signals and when door is open it is automatically off and not performing any operations and third is a development ID in which how to development so we use a MPLAB IDE which is a give me platform to develop the environment and integrated debugging project management and XC8 compiler for optimizing embedded C code generations and simulation platform. For this, we use PICSIMLAB first complete circuit simulation with the virtual peripherals enabling through the testing and debugging the before the hardware implementation and reducing the development time at first. System architecture and operational flow. And first system initialize power on showing on the display and initialize the microcontroller, configure input output ports, set up the timer interrupts and display welcome screen on the LCD. Second is mode selection in which we give four modes first microwave, grill, defaults and reheat LCD display available options and current selections. Third is the time input in which we give a time for a particular operation perform. User interface enters desired cooking duration in minutes, seconds using a numeric keypad. Fourth is a cooking operation. This is a give a start key initiate the cooking after the door sensor verifications. Timer interrupt derive the countdown display while monitoring the pause stop commands. And fifth is completions. When a timer reaches zero, buzzer is sound a completion alert, microwave stop, and LCD prompt. Used to remove food safety. Safety interlock features in which we use the door sensor continuously monitored throughout the operations. Any door opening immediately pause cooking and display warning message, preventing operation until the door is securely closed. Technical challenges and engineering solutions. Real-time time, real-time timer accuracy. Uh, Challenges is maintaining precise countdown timing while the handling multiple interrupt sources and peripheral operations simultaneously. Uh, its solution is implement timers with optimize the descaler and configuration and the interrupt the priority management, achieving the second level accuracy through the careful register configuration. Second is keypad debouncing. My challenge is mechanical switches bouncing caused multiple false keys plus registrations and leading to unreliable user input, erratic system behavior. Its solution is a developer software debouncing algorithm with 50 ms delay validations and combined with the state machine logic ensures a single reliable key press detection. And the third is a safety interlock implementation. My challenge is ensuring the foolproof operation prevention when the door is open while maintaining the responsive system behavior and its user feedback. Its solution is integrated continuous door sensors and what is the simulation debugging? So it's a challenge to fix some lab timing difference from the real hardware peripheral synchronization issues, complicated testing and validation process. Its solution is addressing simulation clock time setting and implemented systematic debugging with breakpoints and created a comprehensive test cases for the enhanced functional module. Comprehensive learning outcome in which we during a past 4 weeks. In first week, we learn embedded C programming, master C, in which we gain the hands-on proficiency in the embedded C programming, especially for PIC microcontroller, including register level programming. And the second is a peripheral interfacing expertise, in which we developed a comprehensive skill in interfacing programming multiple peripheral LCD display matrix, buzzers, and etc. And studies the real-time system design in which we design a real-time configuration and real-time task scheduling essential for the creating responsive embedded application with precise timing requirements. And the fourth is simulation debugging skills in which we acquired a practical experience in simulation-based development and debugging methodology, bridging a theoretical concept with the practical implementation through the systematic set testing approach. Technical concept covered. During this internship, we covered uh, embedded system architecture and categories, microcontroller components architectures, PICS 16F at 77 peripheral modules. It's part of the type of the microcontrollers and the ports and pin input output configuration, tactile switching, matrix, keypad interfacing, interrupt handling, and prioritizations and timer programming and prescaler and post-scalers. LCD interfacing protocol, ICE, I2C communication protocol, EEPROM data storage, and watchdog timer implementation. My project demonstration and the system block diagrams, in which we divided 5 parts. In first, PIC6F 887 core. This is a microcontroller memory. Central processing unit managing all the operations, interrupt handling, and peripheral coordinations. Input interface. It is a 4 cross 4 matrix keypad connected to the port B for mode selection and a time input. Safety sensors. This is a door interlock which switches in ensuring the safe operation protocols. Display module. It is showing what mode is performing, real-time status and countdown. Alert system, in which we use buzzers. That's module for complication, alert and error notifications. Future enhancement and career impact. Hardware implementation pathway in which transition from simulation of actual hardware protocol prototypes using a physical FIC 16F887 development board, real LCD module, and complete verifier integration for the tangible product demonstration. Second, smart feature integration. Incorporate IoT connectivity by Wi-Fi, Bluetooth module, enable smartphone control, remote monitoring, recipe download and integrations with the smart home ecosystem for the module connect convenience. Advanced functionalities in which we add temperature sensing and buzzer like alarm systems and it's adjusts power adjusting and voice controller interfacing enhance the user experience and automations. Professional development impact. It's the first strong foundation. Extensive internship establish a solid embedded system foundation, cover the essential concept from basic microcontroller architecture to advanced real-time system design. Interesting readiness. Gain the practical skill directly application to professional embedded firmware development roles in IoT, industrial automations, consumer electronics, and the automatic sectors. Career trajectory in which well prepared for embedded system engineer position with the hands-on experience in the complete product development cycle from the concept to simulator testing. Now I am going to demonstrate my the project micro oven. Uh, okay, MPLAB XIDE. This is a programming platform for embedded C. It's late sometimes. Okay. Now this is my project file micro oven. This is the header files and source files. In header file clcd dot h file and microwave files and for timers and now I am going to source files. This is clcd source files. You can see that all the codes and this is a main C. It's include all the operation performing the power on and show the menu and time set the time temperature etc all of these and this is a matrix keypad source files. You can see the all the codes for set the times and the temperatures. This is a main microwave.c files. You can see that all the code of the source files of microwave source files. Now I am going to compile all the codes. Click here, right click and clean and bold. Okay, you can see that it's bold successfully. Total times 456 microseconds. It's a little small time. You can see there is no error. Okay, now you can see here. This is microom.x hex file. You can upload this in for simulation of a PICSIMLAB. Okay, here you can see we upload the load hex file, which is generated by the compiler all the codes. Microwave.x, okay, powering on microwave oven is started. It's so all the menu micro grill convection stored. This is a clock you can set it's 20, and the display you can change the 16 cross 2 and 16 cross 4. Okay, reset. Okay. For example, microwave oven and so menu micro grill convection and start, and you can select anyone. Now I am selecting from keypads one. We select a time power 900 watt, and here you can enter the time for cooking time. Now I am entering 5 seconds. Okay, if unfortunately you can edit this, uh, so edit 5 seconds, just click the star, and you can see that 00. Now let it take times for 20 seconds. Okay, you can push the button as for enter. You can see that time is on 20 seconds. Then you can pause the cooking. Click the from 5. You can see here the cooking is pause, and you can start from clicking 4. You can see that the time is on, and this is start. When time is over, it's so time up. Enjoy your meals. Okay. Now I am selecting second grill by clicking 2. Uh, Set time for let's 10 seconds. Okay. For enter as you can see here, the time is start, and you can stop this by clicking pause, and starts time up user minutes. Now I am a convection mode by clicking 3. Set the temperatures. Let's see temperature 5 for clear, and I will click 9. Okay, enter. As you can see here, preheating time given 1 minute. It's remaining 53 seconds, 52 seconds, 51 seconds. When time is over, then it's so the your meal is ready, and enjoy your meal. Okay, so you can wait here for 30 seconds. You can see that this is a buzzer, and this is a heaters, and this is a cooler, and this in right side 2 blocks white blocks. This is a relay. When power is on, when power is off is so relay, and this is a power showing, but and this is a reset. If any error, you can push the reset button and restart. You can see time is off, and now I am to set time for 05. Okay, time up. Enjoy your meal. and start for by clicking start. It take some time, then restart again the the display menu, and you can see here this is a microcontroller chip pic section F877A. This is a power button when can switch off and on. So I conclude my demonstration microwave oven project. This is successfully handled the real-time cooking control, safety mechanism, and user interaction. So there is a chance for future implementation could include like IoT interactions, remote control, and AI-based cooking adjustment data. I am done my demonstrations. I am very much thankful to all of you. Thank you, everyone.